Okay, today we will continue our lesson, computing lessons. We will talk about how can we find the limits of a radical and how can we find limits in piecewise function. Now, we said in the previous periods talk about how can we find the limits of polynomials and rational functions when x approaches a. We said if we have limit x squared minus 16 over x minus 4 when x approaches to 4. And since 4 here is a 0 of the denominator, so I have to simplify. We said it is limit. Let's now rationalize or simplify the numerator. It will be x minus 4 over x plus 4 over x minus 4 when x approaches 4. Then x minus 4 cancel x minus 4, so it will be limit x plus 4 when x approaches 4. Then it comes like a polynomial function. 4 plus 4 equal 8. That's we are we were talking about it in the previous periods. Talk about how can we find the limits of polynomials and rational functions. Today now we learn how can we find the limits involving radicals. If we have now radicals, how can we find the limit? Look at this example here. In this one here, you have to find the limit of x minus 1 over square root of x minus 1 when x approaches 1. Now, is 1 is a 0 of a function of the denominator? Yes. So, I have to take action. Look at me here, what you have to do. You have to say its limit. Now, x minus 1 over x squared, or square root of x, minus 1. Then, after that, square root of x minus 1. If you want now to multiply with its opposite, what it will be? Square root of x, keep it as it is. Then, this minus, write it as a plus 1. So just change the sign. Square root of x minus 1, write it as a square root of x plus 1. And since you multiply the numerator, you have also to multiply the denominator. This way we called it rationalize the function. Here we have square root of x minus 1. I just multiply with the square root of x plus 1 over square root of x plus 1. It's like multiplying it with 1. I didn't make any change. It's like 1, but this one is square root of x plus 1 over square root of x plus 1 equal limit. Now, let's now multiply the numerator. It's x minus 1 times square root of x plus 1 over square root of x minus 1 times square root of x plus 1. Now, if you say a minus b times a plus b equal what? A squared minus b squared. If you multiply them, you will get a squared minus b squared. Is it true?
Yes, miss.
Okay, so here now, square root of x multiplied by square root of x, it will be x. Or it will be square root of x squared, and they cancel each other, so it will be x minus 1. if you multiply this term with this term, you will get x minus 1. Up, you will have x minus 1 times square root of x minus 1. Then, as you see, cancel them. So you will have now at the last limit x, when x approaches 1, of square root of x plus 1. Square root of 1 is 1 plus 1. The answer is true. This is now how can you find the limits involving radicals. I will give you another example to be more clearly. Look at number 29 here. In number 29, you have limit x minus 9 over square root of x minus 3 when x approaches 9. Square root of 9 is 3, minus 3 is 0. So 9 is a 0 of the denominator. Now, look at me here. Look at the denominator. The denominator here is square root of x minus 3. So you have to multiply with the square root of x, but now plus 3 over square root of x plus 3. This is the first step. I will go to the denominator. I will go to where we have radical. I say it's square root of x minus 3. It will be square root of x plus 3 over square root of x plus 3. Then after that, let's now multiply the denominator. What you will get? You will keep it as x minus 9 times square root of x plus 3 over. As I told you every time, if you multiply it with its opposite, like x minus 3 times x plus 3, you will get x squared minus 9, just multiplying them. Here is the same. Square root of x multiplied by square root of x is x, or minus 9 multiplied by minus 3 multiplied by positive 3, you will get negative 9. Then they cancel each other. So limit, I have only square root of x plus 3 when x approaches to 9. Then square root of 9 plus 3. Square root of 9 is 3 plus 3 equal 6. Is it clear?
No, miss. Can you repeat it, please?
Okay. In number 29 here, you have limit x minus 9 over square root of x minus 3 when x approaches 9. Now, in this one here, as you see, if you put, or if you evaluate 9 in the denominator, what you will get? Square root of 9 is 3, minus 3 is 0. So it is a number over, or it is a 0 over 0. Because it's a 0 over 0, so we have to take action. What we have to do?
I'm sorry, teacher. We should always, when it's 0, factorize and do stuff.
Yes, when it is 0 over 0, you have to factorize, simplify, even I need some factorize another time, I will repeat it. Even no, I will try to find it from using infinity.
Oh, okay.
Now, so it is 0 over 0, so I have to take action. Look at the denominator here, or look at where we have a radical function. Where we have a radical function, it is in the denominator. We have a square root of x minus 3. Let's now write its opposite, which is square root of x, but instead of x of minus, what? Here, it's square root of x minus 3. You have to write it as square root of x, but plus 3.
Okay, Miss, why you multiply it by the opposite sign?
Because I have to take action. Like, how can you simplify it in the polynomial, in the rational? In the radical here, you have to rationalize. This way we call it rationalize.
Okay.
Okay. Why? Later on I will tell you why. Because if you multiply them, you will make them as x minus 9. Wait, yes. So I multiply by rationalizing the function. Then keep it as limit x minus 9 over square root of x plus 3 over square root of x minus 3 times square root of x plus 3 when x approaches to 9. Then look here now, Yelana. If you multiply square root of x minus 3 multiply by square root of x plus 3, what you will get? This one and this one. If you multiply them, if you multiply x minus 2 times x plus 2, which is did we get x squared minus 4?
Yes.
Here is the same. If you multiply them, you will get x
minus 9.
Exactly. So you will get down x minus 9. Now let's go up. Up here, we have an x minus 9 and square root of x plus 3. Cancel each other. So I will get now limit square root of x plus 3 when x approaches to 9, and you will continue. Now here we have another way also. I will give you the another way and tell me which way you want to choose. Okay, this is the first way, just multiplying by the opposite of the denominator. I will give you now the another way. The another way now, limit x minus 9 over square root of x minus 3 when x approaches 9. X minus 9, can you factorize it? Yes, girls, can you factorize
it? Be factorized.
Yes.
Yes.
How it will be?
Square root of
X minus 3.
X minus 3 and x plus 3.
If it is
x and square root of x plus 3.
Here, okay, it's minus 3 and plus 3, but you say x minus 3 and x plus 3 if you have x squared. But here I have only one x. So how it will be?
Can I make it x and 1?
No.
It will be x minus 3 squared.
You try it like square root
root
of
of
x
x.
times square root of x. Is it true?
Yes.
Here it's x minus 9. This x is a product of square root of x times square root of x. And as I told you before, if they are square root of x squared, it cancel each other, so it's back to x. So I can refactorize it to be as square root of x minus 3 times square root of x plus 3. Over down square root of x minus 3. Then I will cancel them. So I will get now limit square root of x plus 3 when x approaches to 9. And I will get 3 plus 3 equals 6. They have the same answer. Which way we prefer?
This way.
Both are easy, but this is faster.
Yes, this is faster.
Okay, so I will keep using the second way. In the first way, I just multiply with its opposite and then simplify. Here, no. Here I factorize the denominator and simplify.
Mass, I always, in the first way, I always multiply in the different sign, in the opposite sign.
Yes. Now let's do 30. Limit 4 minus y over 2 minus square root of y when x approaches 4. 4 minus 4 is 0 over 2 minus 2 is 0, so it is 0 over 0. So let's take an action. What you have to do first here, I factorize 4 minus y. It's like a squared minus b squared. So a, which is 4, I can write it as 2 times 2. And negative y, I can write it as negative square root of y, positive square root of y, using a squared minus b squared. It is a and b, a and b. One times one is minus and the other is plus. So it will be 2 minus square root of y times 2 plus the square root of y over 2 minus square root of y. After that, now, can I simplify? Yes. So limit 2 plus square root of y over 1 when limit of x, when x approaches to 4 is equal to 2 plus square root of 4, which is 2 plus 2 equal 4. So now I can find or can compute the limit if we have a radical form. Is it clear now?
Yes.
Yes, teacher.
Okay. Shall we take another example or is it clear?
No, let's take another one, Miss.
Yes? Let's
Yes.
take another. Okay. Limit x16 minus x over square root of x minus 4. Let's now factorize the denominator. It will be limit 4 minus square root of x plus square root of x over square root of x minus 4. Now we simplify it. X square root of x minus 4 and 4 minus square root of x. If you simplify it, what you will get?
8. The final answer.
No, I didn't talk about the final answer. I talk about how to, can you simplify?
The x minus 4.
You cannot cancel them with 1.
Take the negative.
Negative 1, thank you. It will be negative 1. Because if you up here, the denominator, if you take negative 1 as a common factor, you will have x square root of x minus 4 times 4 plus square root of x over square root of x minus 4. Then cancel each other. So you will have negative 1 times 4 plus square root of x when x approaches to 16. Negative 1 times 4 plus square root of 16 is 4. So the answer is negative 8. Is it clear now?
Yes, miss.
Okay. Now let's talk about the limits of piecewise defined function. For functions that are defined piecewise, a two-sided limit is a point where the formula changed its best obtained by one. Okay, look at this one here. For the function f of x, this point, as you see it, for this one, which is negative 2, as you see, they are repeated 2 times. The negative 2 are repeated 2 times. So this point, negative 2, we name it as a point of change. So this point, we name it as a point of change. And also negative 3. 3. They are repeated 2 times, so we call it also a point of change. Why point of change? Because if the number is less than negative 2, I have used a function. And if the number is greater than negative 2, I will use another function. That's why we call them a point of change. Now, at this point of change, we have two-sided limits. So a point of change, that's mean we have two-sided limit. I will tell you later on how. But for negative 2, as you see, and 0.3, they are a point of change. And these points of change mean that we have two-sided limit. But if there's a number 1 as an example, number 1 is here. It is between negative 2 and 3. It's not a point of change. So only at number 1, we have one-sided limit. Let's now do an examples. Let's do A now. With A, limit f of x when x approaches negative 2. At point negative 2 here, where's negative 2? Is it here and here? So which function I have to choose? I have to take both of them. I say It is limit f of x when x approaches -2 from the right, and limit f of x when x approaches -2 from the left. Now, -2 from the right, what does it mean? It's mean -1, 0, 1, 2. So which function I have to choose now? X squared minus 5 or 1 over x plus 2? Yes? Yes, grade 11.
Can you repeat your question?
Now here, limit f of x when x approaches -2 from the right. Okay? Where's -2 from the right?
X squared minus 5.
You will choose x squared minus 5. Thank you. Because here we have -2 from the right. I'm talking about values that they are greater than -2. So I will choose limit x squared minus 5 when x approaches to -2 from the right. Then let's evaluate. -2 squared is 4, plus minus 5, sorry, is -1. So limit f of x when x approaches -2 from the right is -1. Now what about limit when x approaches -2, but now from the left, when it's less than -2?
The first one?
The first one, thank you. 1 over x plus 2. So limit x when x approaches to -2 from the left. Now, let's now remember when you have 1 over x minus a, when x approaches to a from the left and from the right, the function was like this, is it right? We talked it in the previous lessons.
Yes, miss.
Okay, so here, -2 to the from the left. I have the same as this function. And here we have -2. From the left, it approaches to what? To positive or negative infinity?
Negative infinity.
Negative infinity. So, limit f of x when x approaches -2 from the right is -1, and from the left is negative infinity. They are existed now? They are not
Yes, miss.
existed. No, they are not existed. Here you have -1, and here you have negative infinity. It's clear. Shall it's clear or I repeat it?
Teacher?
Yes.
Now, when we can't factorize, we just use the infinity.
When we can factorize
Or evaluate,
this
يعني.
is 1 over function.
Yes.
Yes, it will be only infinity, positive or negative infinity.
Okay. Thank you.
You are welcome. Because Dareen, it likes 1 over, as an example, x approaches to 2 and x minus 2. It's like 1 over 0, which is infinity. Now, limit a, is it clear? Or shall I repeat it?
No, miss, it's clear.
Okay, now let's do B. No. Now, so at point -2, because -2 are points of change, so we have two-sided limit. Look at point 3, at C also, for C. I'm sorry. For C now, limit f of x when x approaches 3. Where is the 3? Here is a 3. Is it a point of change? It's repeated 2 times? Yes. So because the 3, it's a point of change, so we have two-sided limits. So that's mean I have to find limit f of x when x approaches 3 from the right, and limit f of x when x approaches 3 from the left. Then limit f of x when x approaches 3 from the right. It means that I'm talking about points that's greater than 3. So if you look here, points greater than 3. What does it mean? It's mean 3, 4, and 5. So this function. So I say limit square root of x plus 13 when x approaches 3 from the right. We will continue later. Not about now 3, but from the left. 3 from the left, that means it approaches to 3. So here, so I will choose x squared minus 5 when x approaches 3 from the left. Now, let's go to the previous, to the 3 from the right. 3 plus 13 is square root of 16, which equal 4. So the answer here is 4. Look at 3 from the left. We also put 3 squared minus 5. 9 minus 5 is what? Also 4. Are they from the right and from the left, are they same? Yes, they are the same. So because of that, so I can say limit f of x when x approaches to 3 is equal to 4. I'll not say it's not existed because they are the same. I say yes, it's existed and it's equal 4. Now let's do, before I go to B, is it clear?
Yes,
Yes.
miss.
Now let's do B. In B here, we have to find limit f of x when x approaches 0. Look at 0 here. Is 0 is 1 from the point of change? Is it 1 from the point of change?
No.
No.
No. The points of change here only are -2 and 3, but 0 no. Because of that, because 0 is not from the point of change, so does it have one-side or two-sided limit? Does it have one-side or two-sided limit?
One side.
One side.
One
Thank
side.
you. So here we have one side limit. Where's 1? Is it less than -2? Or it's greater than 3? Or it's between -2 and 3?
Between.
Between, thank you. So because 0 is between, I will choose x squared minus 5. Then evaluate 0, and the answer is -5. So I will say limit f of x when x approaches to 0 is equal to -5. I will stop here today. Tomorrow I will give you another example for the piecewise function, and we will start with third lesson, limits of infinity. Is it clear? Grade
Yes.
11.
Yes, sir.
Is it clear?
Yes,
Yes,
Miss.
teacher.
Yes.
Do you have any question?
No, thank you.
Okay. Thank you for listening. Girls, now during this week we have a math quiz for grade 10 and down. But for you, I will not put it for you. Now, next week from 3 October to 3, 4, 5, 6, I think 7 October. Okay? Did you have any exams during this week?
This week we have chemistry.
You have chemistry. Okay.
Yes.
And Sunday, I think you have English
No, Monday we have English.
on Monday. And then
Then let me check.
Economic we have, I think.
I don't know, Miss صراحة يعني.
wait, I will have you have